I'm Krystian Babilinski, and in this session, we're going to learn how Magic Leap makes it possible and easy to port or build new AR solutions. I'm the senior software engineer for the developer relations team, and our team's goal is to make sure that developers have everything they need to succeed on our platform. As a developer myself, I know the struggles of creating on a new platform. That's why it's my personal mission to make sure developers experience the least amount of anxiety when developing on our platform. In this talk, I'll cover an overview of the Magic Leap 2 platform. Then, I'll show you how you can get started developing on the Magic Leap 2. After that, I'll cover a few tools that make it easy to create and port your application, then some technical notes, and finally, we'll have some time for Q&A. So, if you're developing an application for AR, you'd probably want to power it by one of the most advanced AR headsets. Our headset is comprised of three parts. There's the compute pack, the controller, and the headset. The compute pack has a GPU-CPU that is 2 to 3 times faster than the one in the Magic Leap 1. It also has a custom computer vision processing unit, but what I find most exciting is what the chips are actually running. They're running an Android-based operating system, which allows developers to access features using APIs they already know from the Android SDK. It also allows our hardware to have new features, like the ability to tether Wi-Fi via our USB-C charging port. Then we have our controller. Our controller uses a proprietary computer vision technology to maintain accurate tracking even when it's outside of the field of view, even when it's behind the user. And then we have our headset that has the advanced AR optics that allow us to have twice the field of view of the Magic Leap 1, as well as being 20% lighter and 50% smaller. We're also pioneering segmented and global dimming technology. The segmented dimmer allows your application to dim specific parts of the headset so that your content is always bright and visible. In this example, you can see two videos playing side by side. One of them has the segmented dimmer on, and the other one has it off. The one that has the segmented dimmer on has true blacks and vibrant colors. We also have the global dimmer, which allows developers to dynamically adjust the dimming of the complete headset to make sure that the content is always legible and looks its best. We also have a slew of other advanced AR technologies like eye tracking, iris detection, accurate hand tracking, world reconstruction, and fast localization and map merge. And when we were building this advanced AR headset, we knew that the most important feature was to keep it open to developers and enterprises. So we offer a wide range of tools that developers already know how to use. In this talk, I'll be covering Unity and the native tools that it supports, as well as MRTK. So how do you get started developing on the Magic Leap 2? A lot of developers will start off at the Lab 2.0. It's your home base for everything you need to develop on the Magic Leap 2 platform. You can stream mixed reality content from your headset to your computer, or you have access to the Zero Iteration Simulator, which allows you to develop Magic Leap 2 applications even when you don't have a device. You also have access to the Package Manager, which is a place where you can download everything you need as a developer to develop, such as the Magic Leap SDK, or Unity packages. You can even download and update your OS all from this single app. We also have the developer portal, which was built from the ground up to make sure that developers can get familiar with our SDK as fast as possible. We include detailed compatibility charts, examples, samples, and even API references. We also included migration guides and strategies. This sample has been taken directly from our website, which shows developers the changes in code between the ML1 and ML2 controller APIs. And our website also describes platform-specific features, like the segmented dimming, the global dimming, and voice intents. And we know that it's difficult for developers to integrate new platform features. That's why our SDK team has been hard at work to make sure that your application can have the support of those features as easily as possible. For example, adding segmented dimming to your application is as easy as adding an additional render feature to the render pipeline. Adjusting the global dimming value is as easy as as adjusting the global dimming value in the code. And developers can specify voice commands in a scriptable object and then listen to a voice intent event to retrieve when it was said and if it was accurately said for the voice command. Our documentation also describes our shift to the Android-based operating system and what type of APIs were shifted to support native Android equivalent ones. For example, now developers have access to Android permissions, Android intents, and haptic feedback, all through the Android SDK. Our shift to the Android-based operating system also allows developers new features. For example, access to the Android connectivity API. So developers can access Bluetooth and Wi-Fi Direct the same way they would on an Android device. Developers can also create applications and plugins using the native Android SDK and NDK. So now that you know more about the device and how to get started with it, I want to share a few tools that make it easy to port or create new applications. In this talk, I will cover AR Foundations, the XR Interaction Toolkit, and Microsoft's Mixed Reality Toolkit. But before I start, I want to mention something that you'll have to adjust regardless of what toolkit you use. One of those is camera settings. When you're starting to build an application for Magic Leap, you'll have to adjust your camera to render the environment as black instead of a skybox. This is so that virtual content doesn't render on top of the real world. We also recommend that developers add the Magic Leap camera component. This component adjusts the virtual camera's field of view to the physical device. It also allows developers to specify a stabilization distance to make sure that virtual content is stable and doesn't drift. Developers can also specify a focus point to make sure that mixed reality content aligns accurately when they're using mixed reality capture. That is, when they're capturing real-world content with virtual content on top of it. I also want to advocate for the use of our zero-iteration simulator. It allows developers to use or develop the Magic Leap 2 even when their device isn't booted or is simply unavailable. And if your device is available, you're able to iterate and test your application more quickly because you won't have to deploy and build it every single time. These features are available through the Lab 2.0 and now also directly inside of Unity using an additional Unity package. So with those tools and the camera steps, we can start developing. If you're not familiar with AR Foundations is a cross-platform API that is built and supported by Unity. It also supports mobile devices as well as wearable ones, like the Magic Leap headset. The Magic Leap 2 supports AR Foundations natively. Supporting or creating your application should be easy. In this slide, you can see a compatibility chart that shows all of the features that the Magic Leap 2 supports on AR Foundations currently. Now, remember, adding specific Magic Leap 2 features requires the Magic Leap 2 SDK. Let's say you have an AR Foundations application, or you're just familiar with AR Foundations in general. There are a few considerations to make note of when porting or creating your application. A normal AR Foundations app for mobile will probably have a 2D user interface. This user interface will have to be configured from 2D to 3D space because screen space canvases are not supported on the Magic Leap. Touch input, or touch gestures, are also not supported the same way that they are on a mobile device. Developers will have to configure their inputs to make sure that they run on the Magic Leap and use things like the controller, or your hands, or voice. Lastly, developers who are accessing the AR camera background in AR Foundations will have to configure their API to use the Magic Leap 2's camera API because AR camera background is not supported on the Magic Leap 2. So an overview, if you have an existing application for AR Foundations, porting it should be pretty straightforward because AR Foundations allows you to access the same features across multiple devices using the same API. For example, if you're querying for planes on a mobile device and using AR Core and AR Kit, you'll use those same APIs to query for planes on the Magic Leap 2. But remember, not all features are supported. For example, face meshing and AR camera background are not supported on the Magic Leap 2. But because of its native support, deploying an AR Foundations application is straightforward, and some examples even run right out of the box. Just install the Magic Leap SDK and configure your XR device manager to the Magic Leap 2. In this example, you can see me scanning my living room and the walls and ceiling and floor being systematically labeled in the application. But what if your application has more interactions or is a VR application? You're probably using XR Interaction Toolkit. XR Interaction Toolkit is a cross-platform interaction system for both AR and VR devices. It uses actions to reference controller input, and it's built and supported by Unity just like AR Foundations. And just like AR Foundations, Magic Leap 2 support is native. Because of the wide range of devices that XR Interaction Toolkit supports, you might have to configure certain inputs for the Magic Leap 2, because the generic inputs are mapped to things like the controller axis or the controller joystick. But this should be pretty straightforward because Magic Leap 2 has native support for the new Unity input system. So in this example, for the XR Interaction sample, you can simply configure the XR Interaction joystick to map to the touchpad on the Magic Leap 2 controller. And being fully integrated with XR Interaction Toolkit also allows developers to access our device's poses in a variety of ways. If a user wants to get the headset position, they can use a tracked pose driver, or they can use a device-based input from the XR Interaction Toolkit directly, or an action-based input. We've also extended those types of interactions to things like our gaze fixation point, or the left and right eye positions. So if you have an application running on XR Interaction Toolkit, there's a few things you need to remember. You will have to upgrade your application to 2022. After that, you will need to configure a few inputs where needed. Update your camera settings, and then add the Magic Leap SDK to get access to the Magic Leap specific features. In this example, you can see that I was able to port an existing sample from the XR Interaction Toolkit that was developed for VR by simply disabling one of the controllers and configuring some of the input. Now, we already have developers that are taking advantage of our open platform, and they've been able to port their application to our device. HoloOne has been able to port Sphere, which is a cross-platform communications application, to our hardware. And to tell you more about it, we're going to have HoloOne CEO Stev Brunner come up. Or not. But they were able to port the application using the open cross-platform tools. And we know that developing cross-platform applications is easier when you have cross-platform tools. That's why we're committed to supporting tools like Microsoft's Mixed Reality Toolkit. Microsoft's Mixed Reality Toolkit is among the most popular cross-platform interaction toolkits that supports a wide range of interactions. It's open source and developed by Microsoft, so developers, when they find bugs, can resolve them using GitHub. And Magic Leap 2 support can be added using an external package. Currently, these are the following features that the Magic Leap 2 supports on MRTK. Camera system, eye tracking, voice commands, hand tracking, controller haptics, and more features like plane finding and meshing are coming soon. If you want to start developing a Magic Leap 2 application using MRTK, you can start by downloading the tools, which can now be downloaded straight from the package manager. Afterwards, you should upgrade your project to 2022. And then, if you already have an existing MRTK application or project that you're porting into, you need to make sure that your application supports both the old and new input methods. Finally, developers are encouraged to upgrade to the Universal Render Pipeline. Although you can use Standard, upgrading to the Universal Render Pipeline provides access to features specific to the Magic Leap, like segmented dimming. So After you import your package, there's a few things we ask developers to take a look at. One is the pre-configured profiles, and the other are the example scenes. We've extended our example scenes to highlight the features that Magic Leap 2 supports, so now we have additional examples like controllers, voice, gaze, all in separate ones instead of just having it in one scene. Before you deploy your application, you need to make sure that you enable specific permissions so they work inside of your application. If you're using hand tracking, eye tracking, or voice intents, you will need to make sure that you enable them in your application's manifest settings. Additional features or permissions can be requested using the native Android API. Afterwards, you can build your application. So if you have an application and you want to deploy it to the Magic Leap 2, you'll download the MRTK Magic Leap package from the package manager, upgrade your input handling, and then replace or reconfigure your MRTK profiles. Finally, enable the correct permissions, and then build and run. In this example, you can see that I've been able to port the Microsoft's hand interaction demo to the Magic Leap 2. And this example is also available in the Magic Leap MRTK package. A few technical notes about our platform. One is that since our device runs an Android-based OS, it can run native Android applications and plugins as long as they're compiled for the x86-64 architecture. With the exception of multimedia APIs like camera, microphone, and audio output, a lot of the Magic Leap 1 APIs have been migrated to their Android equivalents. For example, permissions. And all applications that are running on the Magic Leap 2 will have to be upgraded to Unity version 2022. And yes, OpenXR support is on the roadmap and coming soon, as well as support for the MRTK v3. We are constantly looking for more cross-platform solutions that we can bring into the Magic Leap and share them across the developer community. For example, Agora.io allows developers to implement enterprise-quality voice, video, and text chat by simply dragging a prefab. And they accredit their ability to port their application to the Magic Leap 2 due to the open platform and that we support the Android operating system. I think the Magic Leap 2 can really redefine what kind of functionality, looks, or the functionality and looks of an AR application, but the Magic Leap alone can't do it by itself. We need developers like everyone in this room to make that change happen. And I recommend that everyone sign up for the Magic Leap 2 developer program so we can get feedback about our device and so you can start porting your application. And we have time for questions. We have 6 minutes for questions if anyone has any.
Anyone have questions?
Okay, well, I was just going to ask if you could jump back to the slide where Magic Leap 1 app could be ported to ML2. But maybe a more expanded out question is, what is the fundamental core differences in the apps? Is it just because of the new architecture of the device?
So a lot of the porting that developers will have to do is because of the extended support for native features. For example, the new Unity input system allows developers to more generically reference our device's features. So in the old Magic Leap 1, we had a controller that you had to reference through Magic Leap Controller, but now you no longer have to reference the Magic Leap Controller, you can just reference the input action directly in the input manager.
Is that okay?
Sure.
Sorry.
I have all the power.
Sorry, no one's asking.
Any other
This will be a
questions
loss,
while we're
yeah.
waiting?
Do you see a future without Unity?
Excuse me?
A Magic Leap 2 future without Unity?
You can develop on the Magic Leap 2 without using Unity. You can use the Android SDK and Android to develop applications, and we actually provide samples and examples on our developer portal for that as well.
Cool, thank you. You think Scene Form would work with it?
See?
Scene Form.
I'm not.
Scene Form is an overlay on top of AR Core, which is... Anyway, we'll connect with you later.
Yeah, if you join the developer program, we'll get the feedback and learn more about your developer process. Encore, and I can go through it again. I'm just kidding.
Yeah, I just have probably a quick one. So what CPU SoC used in the tethered puck?
What type of CPU?
Yeah.
I don't know off the top. I don't know at the top of my head. It's AMD Zen 2 based.
Okay. Okay, that's fair enough.
Any other questions? We have time for one or two more. Yeah. Oh, I'll get you next.
Yeah, perfect.
Hey, to use the 5G with Magic Leap 2, what we need to do?
Can you repeat that?
I'm sorry, to use the 5G with Magic Leap 2, which or any thing we need to do, we do that? Do we need to have a dongle or something else to plug in Magic Leap 2 and to use the 5G network?
The tether? Yeah. You can, there's a question like what the tether, sorry. Oh, the 5G? Yeah, you can tether it using a USB-C cable. So if you have like a phone and you do, it's kind of like on an Android device where you do USB-C tethering to your computer, you can just enable it.
Thank you.
Okay, one last question.
Here we go. Could you maybe share some real case situations where you would want to dim out certain parts of your vision?
Yeah, so
really
if you've
curious.
ever used the HoloLens or the Magic Leap 1, or any AR device really, and you have a bright window in the room, then you can start seeing that the content isn't clear. And we recommend that you go to our booth at 305 and check it out, and you'll be able to see how that can make the whole experience feel a lot more powerful.
We can hands-on try on the Magic Leap tomorrow.
Yeah, we're here, so.
Perfect, perfect. Thanks.
All right, thank you, Krystian. Great presentation. Great.